So first of all, this says, what are the zeros? That means solve this. And then we'll go through and answer the next question. So if we have a quadratic here, we know to solve it, we set it equal to 0. And then we solve it using the most appropriate method, right? What's the most appropriate method for this one? Just shout it out. What should I do? Yeah, solve for x. So subtract 100. Now, a lot of you just floated 100 over. Use algebra because a lot of you missed it because of what you did. You just took it right over. Or guess what people do? They take the square root right here. And that's wrong. You got to use algebra. So you have this. X squared equals negative 100. If you square root it right here, you might mess up. So now we'll square root it, correct? Root cancels out with power. X is equal to 10i. What else? Good, plus or minus. So I saw somebody split it up, which I liked. X equals positive 10i and x equals negative 10i. If you didn't split it up, that's okay for this one. We've answered the first question. We found the zeros. So this is a quadratic that never crosses the x-axis, but those are still considered zeros or solutions. So now it's asking us to write the polynomial as the product of two linear factors. So if you remember back on the homework, if it factors, great, we would just factor it. It doesn't factor, but we can still technically write it in its factored form going backwards. So given the zeros, we can work backwards. So what if we subtract 10i, get it equal to 0? So we would have x minus 10i equals 0. We'd add 10i, we'd have x plus 10i equals 0. Then we have to write them as a product. So look, linear, there's a linear factor. We have x minus 10i times x plus 10i. How many of you got that one 100% correct? Raise your hand. Woohoo! I saw a lot of good things out there. If not, make yourself a little note that whatever you missed, to not do that on the test. You will be tested on that on our exam. Okay, awesome. Now it's asking us to factor this expression. I saw somebody out there doing long factoring, which was great. That was awesome. In fact, you're going to get the right answer too. So that's great. I'm not against that at all. So those of you that long factor, great. Now, some of you, though, did make it easier on yourself, and that's great too. You said, okay, I see that this is two perfect squares. It's the difference of two perfect squares. So we know a little trick to factoring this a little bit quicker if we remember it. If not, you'll get the same answer, which is fine. So square root 10x squared, what do we get? 10x, and then we square root 9, we get 3. And then because the middle term is canceled out, what do these need to be? Plus and minus, or what that's called mathematically are conjugates. Conjugates make middle terms cancel out. So you guys are awesome. That would be stop there. Don't solve it because it didn't ask you to solve. Does everybody see how some of you kind of went too far? You solved it, but then some of you solved it and then you went backwards and you wrote it like this. X plus 10, 3/10. X plus 3/10 like this. And then x minus 3/10. Just a reminder, I marked some down because what you should have done is this. If you have x is equal to positive 3/10, shouldn't we be timesing by 10 first and then subtracting 3? So just a reminder for you. If you have the right answer, you don't want to just get marked off something little. If you have the right answer. Okay, good job, everybody. Okay, let's get on 1-1 so we can go slow, so we can practice in class and make sure we're good to go. It's a short day, so we're going to start right away. Just a reminder. So here are the things we're going to be learning today. Okay, we're going to be able to use a graph to determine key features of a polynomial. We're going to be able to identify key features of a polynomial also based on the equation. So it's graph and the equation. Here are the key factors we're going to be looking at today. We're going to be looking at the degrees, the end behavior, and max and min values. All right. So everybody, we know what standard form is. So just a reminder, we're going to need polynomials in standard form. That makes sense. Standard form is the highest degree to the lowest degree. So look, degree 3, degree 2, degree 1, and then technically degree 0 or constant. So if we have a polynomial, it needs to be in standard form. Now, that's the first rule here. And then once you do that, you can give it a name. So just like you and I have a first and last name, all polynomials also have a first and last name. This is already written down for you, if you'll notice, on 1-1 on the front of your worksheet. So you can just look at it and take it all in. So first of all, its first name comes from the degree, the highest degree. That's why you need it in standard form. And its second name comes from the number of terms it has. So let's talk about the first name first of all. So if it's degree 0, so if it's x to the 0, like here's an example of that, because 5 is really 5x to the 0 technically. It's just we know anything to the 0 power is 1, that's why we just write it as 5. That's called a constant. So degree 0 is a constant, which makes sense. There's a constant number 5. If it's degree 1, x to the first, look, x to the first, it's called linear. It's a line. It makes sense. These names should be pretty easy for us to memorize. Right here, degree 2. So degree 2 would be a quadratic. We dealt with quadratics in Sec 2, so we should be way comfortable with degree 2 being quadratic. Degree 3 is cubic. So look, degree 3 is cubic. Degree 4 is quartic. Here's a trick I use to remember this. So when you see degree 4, there are 4 quarts in a gallon. 4 quarts in a gallon. So when I see 4, I go 4 quarts in a gallon. Oh yeah, it's quartic. And then degree 5. Degree 5 is quintic. So I don't know if you know this, but some people have 5 babies at once, and that's called having quints. It's easy for me to remember because there used to be a show on the Disney Channel called Quints, and it was about a lady who had 5 babies, and then it was crazy and nuts. You guys won't remember that. You're too young. But there is a show, you can look it up, Disney Quints, and you'll see what I'm talking about. So, quintic. 5 babies is having quints. So when I see degree 5, I go 5 babies is quints, so quintic. Okay, so there's its first name. Now its second name, you give it by the number of terms. So I'm changing colors here. So if it has 1 term, now a reminder, terms are separated by plus or minus signs. So this has 1 term, it's called a monomial. This has 2 terms, it's called a binomial. It makes sense, bi, 2. Monomial is 1 term. If there's 3 terms, it's trinomial, which makes sense. Triangles have 3 points. 2 terms is binomial. So let's just give you different examples. And then, so we have monomial, binomial, trinomial, and then after that, it doesn't have a special name. It's just this. So look, 1, 2, 3, 4. So it doesn't have a special name. It's a polynomial with 4 terms. So if there were 5 terms, we would say a polynomial with 5 terms. Do you see how it doesn't have a special name? Okay, cool. That's its second name. Now I want you to point, like on the test, you don't want to miss something this easy. So I just want to point something out. The last name is always the eel. Eel, so people will switch them. Last name is always eel. Okay, here we go. So don't take notes. This is too easy. You're going to practice on your own worksheet. So if I said to you name this, you would say I need to put it in standard form, 9x squared plus 3x plus 5, and you're just watching. And then we would go ahead and name it. So we'd say the highest degree is 2. That's its first name, so it is quadratic. Then its last name is from the number of terms, which is 3, so trinomial. It's a quadratic trinomial. Pretty easy. Right here, we would need to first combine like terms, put it in standard form, and simplify it. So x to the 4th, no x to the cubes. There's negative 6x squared plus 10x squared, which is 4x squared. And then we have a plus 4x, and then we have a minus 12. So now we'll name it. Highest degree is 4. 4 quarts in a gallon. Quartic. And then there's 1, 2, 3, 4 terms. This doesn't have a special name, so we'd say polynomial of 4 terms. It's pretty easy. I don't think you need another example. You guys get the picture. So I'm going to let you now practice these on your homework for a second. Fly like a maniac through some of these, but if you have to simplify it, do that correctly, because we want to get to the a little bit harder stuff here soon. So practice a few, then we'll move on. Just kidding. That was a joke. Okay, so now we're going to talk about, given a polynomial, we know how to name it now. So now we're going to talk about a couple different things. We're going to talk about the number of turning points a polynomial could have, and we're going to talk about its end behavior. So turning points are where it changes from increasing to decreasing. So like, for example, if we have a quadratic, right here is a turning point because it's decreasing, then it changes to increasing. So that's what a turning point is. And then end behavior is what happens to the far left and right of the graph. So like right here, and over here, what's happening. So how we look at number of turning points a polynomial could have, and the end behavior is a couple different things. So first of all, it says the degree of a polynomial affects the shape and the max number of turning points a graph can have. The leading coefficient will also affect the end behavior. So what we do to do any of this stuff is we just look at this leading thing here. So we would look at degree 4, and we would look at the leading coefficient. Degree 3, the leading coefficient. Degree 2, the leading coefficient. That's all that matters. It's going to affect all this stuff. Degree 3 and the leading coefficient. So here is the first rule. So while looking up here, you're not going to want to write down all this stuff. I'll tell you what to write down in a second. You're going to want to take this in and understand it. So So first of all, we're going to look at even degrees. So that maybe write down. We're going to talk about even degrees. So I want to show you my first example here. This one is a degree 4. This is graphed here, but we're not looking at a ton of stuff here. We're just going to talk about end behavior first of all. Okay, so degree 4 is an even degree. Everybody agree? 4 is even. Now we look at front. So we look in front and we see 4. So first of all, even has an end behavior either up and up, or look over here, degree 2 is even, or down and down. So maybe write that in, up and up, down and down on your notes. So evens have either up and up or down and down. So what do you notice about even degrees? Even degrees have what are called the same end behavior. It's either up and up. So we read it from left to right. Look, up and up, or down and down. So evens have the same end behavior. Do you get what I mean by the same? Up and up or down and down. Now here, how do we know if it's either up and up or down and down? Well, you'll look at the leading coefficient. If it's positive, then it's always going to be up and up. Now here's a trick. Look, positive people like to smile, so that would have to be up and up. Positive people smile, so it would be up and up. If it's negative in front, negative people frown, so it flips it upside down, so it's down and down. So it makes sense. All right, so that's your first rule. You'll say evens always have the same end behavior, either up and up or down and down. If it's positive, up and up, negative, down and down. Now, we're going to write in this end behavior here, and this is writing it in just like words or describing it. But now we have to write it in what's called calculus notation. So this is the end behavior in more of a formal notation. So everybody look. Right here's my x-axis. Here is my y-axis, or f of x-axis, true? So this is asking you to describe the end behavior with this. It says, as x goes to positive infinity, where's your function going to? Positive infinity. So we would put in positive infinity. Then it says, as x goes to negative infinity, where's your function going to? Also positive infinity. So if we have a rough sketch here, we can very easily do this part. Does that make sense? Okay, let's do the down and down. As x goes to infinity, where's f of x going to? Negative infinity. And as x goes to negative infinity, f of x is going to negative infinity. Any questions on end behavior? Okay, good. So now let's go on and talk about the number of turning points that it could have. So degree 4 has 1, 2, 3 turning points. Remember, changing from increasing to decreasing. So look, decreasing, 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 boom. Now we're increasing, 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 boom. You see? Decreasing, decreasing, boom, and then increasing that way again. So this one has 3 turning points. Now it says it has at most 3 turning points. So we'll come back and say, well, what if it doesn't have 3? Then what? So let's think about degree 2. Degree 2 obviously always has how many turning points? All quadratics would have to have, all parabolas would have to have 1 turning point. So no matter what, a quadratic has 1 turning point. Now fun fact for you, degree 4s could have 3 turning points, like this example. However, there are degree 4 polynomials that only have 1 turning point. So what they'll look like is they won't be a perfect U. A perfect U is always a parabola. But there are degree 4s that kind of look like that. You see how that's definitely not a perfect U? You see how it's all ski-wampus? How many turning points does it have? 1, but it's not degree 2. So degree 4s could have 3 turning points or 1 turning point. So do you see how degree 4 could also have the same turning point as a degree 2? Okay, awesome. It just depends on the polynomial. So here's the rule. If you'll notice something, degree 4 has, I'm writing up here just because there's more room, degree 4 has 3 or 1 turning point. Well, didn't we go down 1 value here? And then down in 2s, which makes sense. And degree 2s have 1 turning point. So if I asked you to put 2 and 2 together, if I said how many turning points do you think degree 6 could have? What would you guess? If you were just guessing going on the pattern. 5, it could, yeah. What else do you think it could have? 3 or 1. So you guys see the pattern. That's always how it works. Okay, good. You guys get it. Awesome. So right here, the number of turning points, you would say, we already said this one. We said 3 or 1. And then on the test, you'd say it could have 3 or 1, and then you could graph it in your graphing calculator and say, but it actually has 3. Does that make sense? You're just saying how many it could have. Okay, now it says find the increasing and decreasing intervals. So we would have to know these x, y points to be able to give exact intervals. We're going to practice that in a minute. So I just want to point out what our intervals would be. So right here, increasing and decreasing is always for x. So we're talking x values. So aren't we decreasing until we hit that x value? Okay, so that would be a decreasing interval. And then aren't we decreasing from this x value to this x value? So we would write that in if we knew those x, y points, but we don't. And then we're increasing from this x value to this x value. And then we'd be increasing from this x value to infinity. So we'll practice that in a minute with something not so nasty and ugly right there. Okay, so our number of turning points here is 1, because it's a quadratic 1. It has to have 1. It couldn't have 0, could it? If it didn't have any, would it be quadratic? Okay, no. Okay, awesome. So now we're increasing and decreasing intervals for this one. This one's not bad, because look, the point is over at x equals 1. So 1, 1 is the point, but it's for increasing and decreasing, we only look at the x values. We're talking x values. So our increasing interval for x would be from negative infinity up to 1. So everybody see how we stop increasing at 1. So negative infinity up to 1. Now, and a turning point isn't increasing or decreasing. If you're at the top of the hill, you're not climbing anymore and you're not going downhill. Our decreasing interval would be from this x value 1 to infinity. So decreasing would be from 1 to infinity. That makes sense how to write it. Okay, cool. Now, oh, that's good. Okay, so let's look at odd. So odd end behavior. Evens have the same end behavior, up and up or down and down. So odd has opposite. Odd, opposite. So odd have opposite end behavior. So it's either going to be from left to right, down and up, or from left to right, it's going to be up and down. Those are opposite end behaviors. Then you look in front. If it's positive in front, it's going to behave like a positive line. Well, why? Because lines are degree 1, which is odd. The end behavior will behave the same. So isn't this a positive line? Look at it from left to right. So it's going to be positive, so it'll be the same as a positive line, down and up. Even though it's not a line, end behavior works the same. So then right here, odd split is opposite, negative, so it'll be like a negative line. From left to right, this is up and down. So that's that in words. So now from here, we'll do it in this formal notation. As x goes to infinity, where's f of x going? Infinity, correct? As x goes to negative infinity, our function goes to negative infinity. You guys are doing good. As x goes to infinity, as x goes to infinity, we go to negative infinity, and as x goes to negative infinity, f of x goes to positive infinity. Okay, let's talk about turning points. Here's a degree 3 that has no turning points. Now, guys, if it's increasing, look, increasing, 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 it slows down, but it doesn't change and go down, decreasing at all. It's just slowing down, but it's still increasing, still increasing, still increasing. So this one had 0 turning points. Well, let's look at another degree 3. So this one is decreasing till it hits this point, 1, 2. This one has 2 turning points. So, look, degree 3 has 2 turning points, or it could have, well, if it had 1, wouldn't it turn and go down like this? But it was a good thought, because that's a good thing to remember, but you meant what? None, yes, 2 or 0. So it works the same way. Look, degree, you go 1 down from that, and then 2 down. It goes down in 2s. Does that make sense? Okay, so it's the same as evens. Just the same idea. So our increasing interval from here, this is strictly increasing. So right here we'd say 2 or 0 turning points. Yes, it actually has 2, but I'm listing out possible number of turning points. All right, here we're increasing from negative infinity to infinity. It's always x values. That's all we care about. So it's strictly increasing. Then right here we're increasing. So I'm going to write this one in because I can see this x value. This x value is at positive 1. I don't care about the y value. This x value is at negative 1, isn't it? Negative 1 and down 1, but we only care about the x value. So we're increasing from here to here, aren't we? That's the only place. So from this x value to this x value, we're increasing. So we're increasing from negative 1 to 1, parentheses, because those values are not increasing or decreasing. Now we're decreasing from negative infinity up to negative 1. It's x values. Negative infinity up to negative 1. People start using y values and then they get something wrong on the test. And this u means also, like union. Also, we're decreasing from this x value to infinity, not negative infinity. We're going x values. So we're decreasing also from 1 to infinity. Make sense? How to do it. Okay, so now I'm just going to test for you in general, and then we're going to be doing good here. So this is already on your worksheet, but we've already talked about all this stuff. This is just putting it in a box for you. But understanding it and just having it memorized how we just practiced is easier. So I'm going to test your knowledge here, okay? So let's just look at this one. If I put a 3 in front, and I said to you, what's the end behavior, what would you say? Up and up. It's even. It's positive. Positive people smile. Up and up. Do you all understand? How many turning points could this one have? 1 and only 1, right? Degree 2s always have 1 turning point. Okay, let's look at this one. Degree 4, let's say I put a negative 2 in front. You would say it's down and down because it's even, and then it's up round, so down and down. How many turning points could it have? 3 or 1. Okay, good. And then right here, if I put a positive 8, you'd say up and up, yeah, and then you're right, so it's up and up, and then you'd say there'd be how many possible turning points? 5, 3, or 1. And then if I said, how many does it actually have, you'd graph it and count. Okay? All good. Okay, you guys get it. Okay, we're doing good. We're almost there to where you can practice. Okay, how many, what's my end behavior? So it's a positive line, correct? So down and up. Okay, good. So then from there, how many turning points does it have? 0, for sure 0. Okay, cool. On this one, let's say I put a negative 2 right here. You'd say odd, so it's opposite. Negative means it's up and down, like a negative line like this. Up and down. So then how many turning points could it have? 2 or 0. Okay, good. And then I'm going to put a 7 here, so you'd say it's down and up, since it's odd opposite, positive down and up, just like this. And then it could have how many at most turning points? 4, 2, or 0. Okay, you guys get it. That's a big part of the lesson today. Okay, cool. So look at these two that I'm going to have you practice them on your homework. So don't write these down because you get it. So let me just show you how I would do it on the test. This is exactly how much work I would show, because you don't want to have to graph it out. In fact, I won't even give you a calculator. You won't be able to use your calculator on this portion of the test. So you say, okay, it's in standard form. It's an odd degree, so it's opposite, right? Then we'd say it's positive, so that would be like this, wouldn't it? Even though it's not a line, we don't care what happens in the middle. I'm asking you end behavior. So isn't it down and up? That's a positive line. So in words, we describe it as this, down and up. Then in calculus notation, we'd say as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. Moving on to this one, you'd say it's in standard form. It's even, so it's the same end behavior. It's either up and up or down and down. It's negative, so it's up round, down and down. So down and down, what the heck? I'm like thinking and writing at the same time. It's too hard to do. So down and down. Okay, as x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. At most, I'm not asking you to tell me exactly how many at most turning points could this one have. 2 or 0. Okay, and then how many turning points at most? 3 or 1. What about 0 here? No, that wouldn't make sense. That wouldn't work. It would not then be down and down. Okay, sweet. You guys get it. So I'm not going to do another example. So what I want you to do for a second, and then we're going to come back to this, is go answer. Let's see. I'm going to look at your homework and tell you which ones to go answer. So go do problems 5 and 6. Just answer the possible number of turning points. Don't do the increasing and decreasing intervals yet. We're going to come back to that. But I want you to answer the end behavior in words, in calculus notation, just like we did in this example, and then the number of possible turning points. So you're going to answer 5 and 6 like this one, and then 3 and 4 you could do. So ready, go. And then we'll talk about how to write out increasing and decreasing. So if I said to you on a test, describe the end behavior in words, you'd say even and negative. So it would be like this, down and down. True? Yes. D and D. I'm just going to write that to be quick. As x goes to infinity, f of x goes to Negative infinity. As x goes to negative infinity, f of x goes to negative infinity. The highest number of possible turning points. 5 or 3 or 1. Okay, good. And then right here, we would say it's odd, so it's opposite. It's positive, so like this. Positive line I just drew in. So it doesn't matter that's not a line because we're just talking end behavior. As x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. The highest number of turning points this one could have. 2 or 0. Okay, good. All right. So now, same thing here, but now I'm going to add in there increasing and decreasing intervals. So we look, if we did look at the graph of this one, this is what it would look like. You see how it's strictly increasing, right? We've seen an example of this. So there are no turning points here, but we have listed out the possible. So you would say there could be 2 or 0, and then you could say, like, underline that one, there is 0. Our increasing intervals, isn't it strictly increasing? So once again, you'd say negative infinity to infinity. And then our decreasing intervals, there's none, since it's strictly increasing. So look right here. I graphed this one, which is degree 3. It looks like this. So we could put in our end behavior, but we're just going to talk about turning points. So at most, this one could have 2 or 0. It actually has 2 turning points, right? Right there and right there. So now it's asking for increasing and decreasing intervals. You have to actually know those turning points. You only focus on their x values. So look, this is over 1 up 2. It doesn't matter that it's up at 2. We want to look at x equals positive 1. This is x equals negative 1. It doesn't matter that it's down at negative 2. So x equals negative 1. So I'm going to draw in my increasing interval. Isn't it from there to there? So my increasing interval is from negative 1 up to 1. X values. Increasing and decreasing is x values with increasing. Does that make sense? From negative 1 to 1, those x values are where it's increasing. For decreasing, coming in from x value negative infinity up to this x value of negative 1. Then we're also decreasing from 1, the x value of 1, to infinity. If you start using y values, you've got to keep your brain looking left and right, because if you start going up and down, you start getting them wrong. Make sense? Okay. Now, these ones are easy because we can see exactly where the x value is, but they're not always going to be that easy. So when they're not, you're going to use your calculator to find those points out. So grab your graphing calculator. I'm going to walk you through how to do it. Now, you do have to be able to recognize right here is a minimum, right here is a maximum. A min, low point, max, high point. You do have to be able to determine a min versus a max. Everybody, I'm going to teach you how to use your calculator. Have it out. Follow me through this. If not, watch very carefully and get one as soon as possible. Practicing the calculator yourself is key to being ready for the test. Easier to watch than to do. Okay, pull up your graphing calculator. The first thing I'm going to teach you is how to reset your calculator like a brand new calculator. You're going to have to do this a lot during the year. If you type something weird and you can't figure out how to fix it, you got to reset your calculator. So let me teach you how. So everybody hit the second key. Second plus sign. That says memory. We're going to reset our memory. So second plus sign. Go down to reset, everybody. We're going to hit 7. And then hit enter. It's asking you, do you want to reset all the RAM? That just means all the information in there. Yes? So hit enter. If you have a game, though, it's going to erase it. Then go down to reset. We do want to reset it. Now you have a brand new calculator. So if your calculator ever wipes out, reset it. It's like having a brand new calculator. Okay, y equals, everybody. We're graphing the polynomial I just gave you, which is x cubed. So right here's x. So x raised to the third power. And then it was minus 2x squared. So I could do caret 2, or I could just do squared. Now hit graph. Now look at the graph. You need to be able to physically see with your eyeballs all the places where there's turning points. Can't we see it? Yeah, it's not a bad window. Now guys, look, it's automatically a standard viewing window, meaning when you have a brand new calculator, the best viewing window, the standard one, is positive 10 on x, negative 10 on x. Negative 10 on y, positive 10 on y. This is a standard viewing window. So let's say that we want to get in closer, zoom in closer so we can see better. We can. We'd want less tick marks, wouldn't we? Think about pulling in, okay? Now let's say you can't see high up, like let's say you can't see a turning point. You can tell it turns, but you can't see high enough up. You'd want to zoom out. You're not going to use the zoom key though, you're going to want to use your brain. Okay, so everybody go to window. I want to get in closer. I can see the turning points, but it's kind of far away. So I'm going to go to window. So hit window. I didn't hit window. What did I hit? Oh. Yeah, you need to hit window. Sorry. So hit window. It's okay. I'm just going to go over to window. Now look, it's the standard viewing window, -10 to 10. Look, x min, that means the lowest point on x. Minimums are negative, so -10. It's up, x max is +10. X still means the tick marks are going in units of 1. We don't want to change that because then we'll be in, like if we change it to 2, it'll be going 2, 4, 6, 8. Do you get it? Okay, it's just really understanding this is key. Y min, it's showing us as far down as -10, and Y max is showing us as high up. So let's say we needed to see higher up. We could change Y max to 15 or 20. You don't have to change them evenly. Does that make sense, everybody? I want to zoom in though, so I'm going to zoom in on X. So I'm going to do X min, I'm going to try -5. You can't type -5 or it's going to say error. X max, I'm going to change to +5. X scale, leave it. Y min. You don't have to change them evenly. Like look at my window, if I hit graph, I can see it pretty good. Can't I see the max and min pretty good? However, I could zoom in. I don't need to see that high up. So on the Y min, I'm going to also do -5 and 5. You don't have to do them the same though. So now I'm going to hit graph and I can see really well now the max and min value. That just makes our life easier. So now what you're going to have to do is you're going to have to say, this is a maximum value right here. I need that turning point so I can do increasing and decreasing intervals. So everybody, you're going to hit, let's find this maximum value right here. So hit second trace, then go down to maximum. You have to know if you're finding a max or min. We are randomly choosing to find the max first. It doesn't matter though. So everybody go to maximum, hit enter. Now look what it's asking you. You have to understand what the calculator is asking you. The calculator can find the value for you, but it has to know where you want to find the maximum, between what and what. So it says left bound. That just means show me where the maximum is that you want me to locate. So what you're going to do is scroll left of the max, like physically from left to right. Look, from left to right. You see how right here is the maximum? I am left of it. Anywhere left will work. It doesn't matter how left, as long as you're left of it. Hit enter. Now it says right bound, so you're just showing it where the maximum is. So I'm scrolling physically to the right of that maximum value. Anywhere right will work. So I'm going to hit enter. Your calculator will now say, do you want me to guess between that interval of where the maximum value is located? Yes, we do. Your calculator will guess correctly, so hit enter. Now my calculator is so exact, it's being a little bit difficult. Some of your calculators are saying 0, 0 right now. Yours is being a little less difficult than mine. Our calculators are so smart, they're almost too smart for their own good. Here's why. Everybody look. It's not over at 3.5. Look, this is 3.5. The E means times 10 to the -7. That means take this decimal and move it back 7 places. So wouldn't that be 0.00003, That's pretty much 0. That's so small, we're just going to call it 0, everybody. And then look right here, the E to the -13. That means take the decimal and move it back 0.0000000. You see, it's pretty much 0, 0, everybody. So watch out for the E. That means it's probably a 0. Let's see where the decimal gets moved. So it's being too smart. So I drew a rough sketch. We go like this, right? Doesn't it bounce down? And then go back up like that? So I just write this in. We have x equals 0, or we could write 0, 0, but our y value doesn't matter. So we found the maximum. Great. Let's find the minimum. That's the lowest value, so it's a minimum. So go second trace again. Second trace, minimum, hit 4. If you put maximum, it's going to wig out. We're finding a minimum. This is left bound. Here's the min. You got to be left of the min. I am left of the min. Look. There it is. I'm left of it. So I hit enter. Now it says right bound. So I got to scroll over and be to the right of it physically. And I am now. So I hit enter. We do want it to guess. And make sure it ends up in the right spot. Uh-oh. What did I do? Oh, I did. See, it wigs out. So we actually need to do second trace. We're finding a minimum, huh? 3. So left bound, I got to redo it. So it's fine. Just be careful because something was off. So left bound, enter. Right bound, enter. Because it's a min. Okay, so look, there's no E's. So those are the decimals. Let's go 1 decimal place. Everybody, So it's over at 1.3, negative 1.2. So over at 1.3 comma negative 1.2. The y value does not matter. So x equals 1.3 is what's important. So now we can write in our increasing and decreasing intervals. Here's my increasing interval, So we'll go like this. Increasing and decreasing, and here we go. X values were increasing, negative infinity up to 0, true? And then we're also union, we're increasing from that x value, which is at 1.3 to infinity. Then our decreasing, I'm just going to abbreviate here, we're decreasing from 0 to 1.3. And it's not too bad. You just have to know how to use your calculator. It's not that it's hard math, it's just the calculator can be kind of hard. Okay, practice that. So if it asks you for increasing and decreasing, you're going to need to use your calculator to find where the turning points are so you can actually answer it. There's the problems. I'm going to give you a while to work. Ready, go. So this is like describing all this really like formally. I'm just going to explain because we don't have a lot of time. We have 10 minutes. So I want to give you time to practice one. So here's the thing, guys. If we're given a set of XY points, we're going to be able to determine the degree. Not right off. Like we have some set of XY points. It's got to be some degree, degree 1, degree 2, degree 3, you know what I mean? Everybody, it's got to be some degree. So here's the first thing you have to check is, are my X values in order from least to greatest? Yes, with negative 3 and to 3. And then make sure you're not missing anything. Like you can't be skipping values. So like if there was a negative 1 missing, this wouldn't work. So if we went from negative 3 to negative 1 to 2, this would not work. It has to be in order from least to greatest and not missing anything. Consecutive. Okay, if it is, then you're only going to look at your y values. Your y values are going to tell you what degree it is. So this is how we can do it. If you subtract your y values the first time and it comes out to be the same value, it would be linear. Let's say you subtract your y values and it doesn't come out to be the same value, it's not linear. So you'll take those new values, subtract again, and if they come out to be the same now, the second time, it'd be quadratic. If they're not the same, you keep going and so on. So let's figure out what degree this is. So you focus on your y value. And here's the important thing to remember. You have to subtract from down to up. So from the lowest up, like from the one underneath the one above it. So we're going to do this. Negative 7 minus 9. If you make one error, the whole thing's downhill. So you got to be really careful. So look, negative 7 minus 9. You always do the value below the value above it. So what's negative 7 minus 9? Negative 16. Okay, write that down. Now we're going to do 9 minus 11. We can't miss anything. 9 minus 11. Negative 2. So we already know it's not going to be linear because it's not the same. Now we're going to keep going because we need all of them. 11 minus 5. 11 minus 5 is positive 6. And if you make one error right here, the whole thing's wrong. It's a bummer. 5 minus negative 3. Positive 8. Negative 3 minus negative 7. So if you need to write it out so you don't mess up, do. Negative 3 minus negative 7. Positive 4. Negative 7 minus negative 1. Okay, so look, the first time we took differences, they were not the same. It's not linear. So now you're going to take differences again. Starting with the value and working up. Just like I said before, you got to do the value before the value above it. Negative 16 minus negative 2. Okay, negative 2 minus 6. Not quadratic, keep going. 6 minus 8. 8 minus 4. 4 minus negative 6. 10. Okay, well it's not quadratic, let's keep going. Negative 14 minus negative 8. Negative 8 minus negative 2. Better keep going though. Negative 2 minus 4. 4 minus 10. Okay, so the third time we took differences, it's the same value. So this would be cubic. The negative 6 has nothing to do with it. It's just that it's the same value. So it's cubic or degree 3. Make sense? Yes. Yeah, if you only look at y's. Now here's one thing to note, okay? Let's pretend they weren't the same. We'd go again. Let's pretend they weren't the same. We'd go again. They weren't the same. We go again, and then we only have one number here. If that happens, it's not that it's 1, 2, 3, 4, 5, degree 6. You can't determine the degree based on the information you were given. It's some degree, but you can't determine. You need more information. Does that make sense? Okay, now if that happens to you, there's a really good chance you have made an error with a negative somewhere. Look, what if we would have messed up here? The whole thing would have been wrong. So that's why you got to be really careful. So if you get all the way to the end and you can't determine the degree, there's a good chance you made an error. If you don't feel like you've made an error, you say, I cannot determine. Make sense? Okay, sweet. That is the end of the lesson. So you could practice one like that before you go. So number